Hey everybody, let me tell you about Gaussian elimination. This is chapter 11, section 6, and it's pretty exciting stuff. We already talked about how matrices end up scattered all over different kinds of industry. I've got a little list here of different people that use matrices regularly. Um, we did say that the big one and the one that we really care about is down here at the bottom with solving equations. And let me show you some of what happened now. If you can kind of go back in time, and I'm not talking about a whole lot of time, like 30 years, 40 years, right? In my lifetime, people were using matrices and doing these things by hand, like I want to show you today, all the time. We didn't have computers and calculators that would do this kind of stuff. NASA probably had computers, but nobody had calculators, 40, 50. My father didn't in college, certainly. They didn't make them, they didn't exist yet. So this is a fairly new thing to where we can just push some buttons and get the answer that we want. But um, so everything was done by hand, and this was how bigger sets of equations were solved. Right here, I'd like to go through and remind you how the elimination method worked, and then show you how that turns into um, matrix Gaussian elimination. If I come in here and I take this system of equations and I kind of work it so that I can knock out some of these terms. Remember, that was the whole thing we were trying to add straight down or to make it so that I could eliminate a variable here. Why don't I just write that first equation over again? And then I'm going to replace the second line with 2 times the first line minus the second line. So it's the same pattern everywhere. I'm going to put it right here. If I take, let's call this row A, and this will be row B here, just to have something to refer to. So I didn't change anything here. This one is the same, nothing changed. But what I'd like to do for row B is I'm going to replace row B with the old row B minus 2 times A. Okay, and you got to do the pattern all the way down to make this thing work out right. But check it out. If I take 2 minus 2 times A, which is 1 here, 2 minus 2 would be a 0 right there. Now I got to do this one. I got a negative 1 minus 2 times 2, that'd be minus 4. So this would be a negative 5, like that. I take the B element here and subtract 2 times that. So 1 minus 2 times 8, that's a 16. 1 minus 16 would be negative 15. Okay. And I replace that row right there. Now, what we used to do was to come in here and we'd say, all right, I'm going to multiply um, the top row by negative 2 minus 4y equals 8. And then here's the 2x minus 1y equals 1. And I would just add straight down and I'd get a 0 and I'd get a negative 5. And I'd get, I forgot to multiply this one by 2. So 1 minus 16 would be the negative 15. And see how that's the same thing that we did right here. So we're kind of just doing it in place, not rewriting the whole thing and making it do the thing. All right. I'm going to leave the top row alone, top equation alone. And then down here, I'm going to replace B with B divided by negative 5. Okay. See that negative 5 right there and the negative 15? There's a common term there. I could cancel that negative 5. If I take 0 divided by negative 5, that would be 0. Negative 5 divided by negative 5 is going to be a 1. Um, If I take negative 15 divided by negative 5, that will be a 3. Okay? So everything in row 2 got divided by negative 5. I ended up with this one right here. You can see that we've already eliminated the x variable, and we're down to y equals 3. That's our first solution right there. Okay? And there are ways that you could take that and substitute that back into one of the original equations and find out what x is. But let's keep going with this here. I'm going to leave that second equation alone now, and that's going to be the same. We're done with equation number 2. And what we want to do now is to work on equation A, the top one, and try to get a 0 right here for y. If I could knock out the other y, then I would know the value of x. So I'm going to look here. I've got a 2, I've got a 1. I could replace line A with A minus 2 times B. Okay? If I took the 2 minus 2 times 1, that would give me the 0 right there that I need. And I've got to do that same pattern. This one, 2 minus 2 times that. So do the same thing here. 1 minus 2 times 0, that's a 0, right? 1 minus 0 is 0. Right here, I'm going to have 8 minus 2 times 3, or 6. So that's going to be a 2, like that. Okay? This is an interesting thing here, because now I know that 1x and no y's is 2, or x equals 2. And this one says that 1y equals 3, or y equals 3. We have solved this thing using Gaussian elimination, where it's essentially the elimination method, but we've kind of taken it in steps and done each one. Now, that's what would happen if we're writing the whole equation. Back in the 1820s, 30s, Gauss, who I've got a picture of him here coming up somewhere, nice guy, um, child prodigy in mathematics and science and literature and everything else, and was a big deal. Okay, might not quite have been Einstein, but he was getting close to that. Newton, and he's one of those guys. He was all over mathematics and physics and just everything science. Um, let's put these in matrices, and again, all I'm doing is taking those two equations, making two rows where the first element of the matrix is the coefficient of the x term, and the second element would be the coefficient of the y term. And then I need an 8 for right there. So there, I've moved that over into a matrix. Here, I've got 2, negative 1, 1 to represent the second equation, and I have my matrix. If I take this first step that we did right here and write that as a matrix, I've got 1, 2, 8. Remember, we didn't change anything on the first row. And then I'm looking at the 0, negative 5, negative 15, like that. I want to take the third third process that we did, write that as a matrix. I would have 1, 2, 8, and 0, 1, 3. This is where we divided the second line by negative 5 to get that down to a 1. And then the last step here was to leave the second line alone and do that thing where we took the 2 minus 2 times 1 would be a 0 right here. And the 8 minus 2 times 3 was a 2. And the 1 minus 2 times 0 is still 1. What we've done here, this is, this was the system of equations that we took. And we made a special kind of matrix here, and we worked with it down here to where we have these ones here, zeros everywhere else except for that last column. If we look at this much right here, that's what's referred to as, it's a diagonal matrix because there's only numbers on the diagonal, but it's also known as the identity matrix because it's ones and zeros, nothing but ones on the diagonal, zeros everywhere else, and then right there. Um, when we get it down to that form, remember that the first column represents the x's and the second column represents the y's and the third column equals the number. You can see that 1 equals 2. There's a little understood equal sign in there. 1x equals 2. So there's our first solution. We can just read it right there. And the second one is right here. This would be 1y equals 3, or y equals 3. Okay, so this was kind of a big deal in the 1800s. They didn't have calculators, computers. This saved writing all those x's and y's and the whole thing. It was a shorthand for doing this process, which was getting more and more necessary. This is the Gaussian elimination. There's Carl Friedrich Gauss, and looks like a nice guy. Again, we took the system of equations. We made this special kind of matrix. It's an augmented matrix because remember we've augmented it. We've added on that extra column to represent the answers of the original equations there. And then we worked with it until it was in this form right here. Sometimes you'll hear this referred to as a reduced row echelon form matrix. One's on the diagonal, everywhere else is zeros. I've got my solutions right there. Remember, this was the x value, this was the y value. Super easy to pick up. There's only two possibilities really here. You can multiply a row by a number. You can add or subtract any two rows to make a new row. And that is Gaussian elimination. I've got some more examples here. It basically comes down to picking a pattern that will cancel out the numbers that you want to, and you got to do that for the whole row. But once you've got the pattern down, it works out pretty nice. Let's see what happens. Right here is one. The first step, of course, would be to write that as a matrix. So I'd have 2, 1, 10. I'm just pulling the numbers, the coefficients off of these things. There's a little invisible 1 there and here. Then I'd have a 1, -2, -5. And that is my matrix. These are what I would like to get over here. I'd like to get A11 equal to 1. And so when I'm talking about A11, that would be, here's this matrix, we'll call it A. The element here is A, but it's in the first row, the first column, so that's A1. And then A21 would be this guy, and A22, that'd be the second row, second column, so down here. I'm sorry, this one. I got them out of order. A12 would be right there. A22 would be in the second row, second column. And I want those to be 0. I want that to be 1, 0, 0, 1. And then I'll have that extra column on there for the answers. This will be X, this will be Y, like you have there. Okay, so I didn't write that very well, but that's what we're trying to do. And you've got several choices. Sometimes it's better to go ahead and see how I could take that top row and divide by 2. That's an option. I've got this 1 right here, which is going to make a fraction right there. So if you don't want to deal with the fraction, then don't divide by 2 just yet. We do want to get a 1 right there, but maybe it's better to wait until after we've got things cleaned up a little bit. I definitely want a 0 right here. So let's work on that. I'm going to take this matrix that we have here, and I'm going to leave the top row the same. Hold off on that. So there's my 2, 1, 10. Okay. And then down here for row B, I'm going to um, take, you can do this several different ways. You could take A minus 2B, right? 2 minus 2 times 1, that would give me a 0 right there. I got to get a 0 there. So we might as well do that. A minus 2 times B. I'm going to take whatever's in the A and subtract 2 times this number. So 2 minus 1 times, I'm sorry, my little dot's not moving over on your screen. The 2 minus 2 times 1 would give me the 0. Do that same thing all the way across. 1 minus 2 times 2 minus a negative is a plus. So I'm really got 1 plus 4 would give me a 5 right there. Now I need to do 10 minus 2 times 5, and 10 minus 10 would be a, hang on, did something silly here. Slide 5. Uh, do. 10 minus, oh, it's a negative. Never mind. Okay, right. 10 minus 2 times a negative 5, that would be 10 plus 10, or 20 right here. If you need to write that out, there's no shame in that. Obviously, I just about goofed it up. This is pretty tedious. So um, what we did here, left the top row the same. Down here, I had the 1 minus 2 times a negative 2. And negative 2 times negative 2 would be positive 4, and 1 plus 4 would be 5. For this one, we're taking A minus 2 times B. So that would be 10 minus 2 times a negative 5. Negative 2 times negative 5 is a positive 10. 10 plus 10 is 20. So write that out if you need to. This gets pretty tricky to keep up with. People used to be better at doing this because they had to, right? They didn't have a calculator they could just feed this into. All right. Next up, I would leave the top row alone again. Anytime you can avoid making fractions, if I do divide by 2, it's going to make a fraction right there. So let's leave this one the same. And then here I've got a 5 and a 20. Those are both divisible by 5. So I'm going to divide both of those by 5, come up right there. This new row B was the old B, divide by 5. And I've got my new row number 2 right there. That's what we were trying to get, right? That's two of the things we were trying to get. I wanted to get A12 equals to 0, and I have that. And I wanted to get A22 equal to 1, and I have that. So I've got two of these things. This row is done. We're not going to touch it again. Every time we write this from here on out, we're just going to keep that the same, and it shouldn't be that many more times. 0, 1, 4 is my bottom row there. Okay. What I'd like to do next is this guy. I'd like to get 2, 1. Oh, I'm checking the wrong boxes, aren't I? These are all out of. Okay. Let's get I should have, not this one. Hang on. I circled the wrong box. 1, 2. We did not do that one yet. We did do this one. Okay. So those two are done. I'm going to hold off on 1, 1 until I can not make a mess with my fractions. But let's concentrate on getting 1, 2 equal. I want a 0 right here. Okay. If I can turn that into a 0 and then eventually this into a 1, then I'll have my two solutions right there, and be ready to hand those on a plate. Okay. What do I got to do to get a 0 there? Looking back at this matrix right here, I've got a 1 there and a 1 there. So really all I have to do is subtract. For this new row A, I'm going to take the old row A and subtract row B. So when I do that, I've had a 1, subtract a 1, I've got a 0 right there. I got to do that all the way across the row though. And so when I do this one, I've got the 2 minus 0 is going to give me a 2 right there. And then I've got the 10 minus b, a minus b, 10 minus 4 would be a 6 right there, like that. Okay. So now we have scratched off this one. We've scratched off this one. We've got this one. And all I got to do is get a 1 out in front right there. Those are both divisible by 2. So it's a good time to come through and take that A, and the new row A is going to be old row A divided by 2. Just divide the whole row by 2, and I'll get a 1, 0, 3, 0, 1, 4. We're not touching this one, right? Same, done. We don't need to mess with row number 2 anymore. We have this down. This is the RREF, reduced row echelon form version of the matrix. We took the original matrix and transformed it into the reduced row echelon form, and that hands us our answers. This is 1x plus 0y equals 3, or x equals 3, and down here I'd have 0x plus 1y equals 4, or y equals 4. That makes it pretty easy to go through and get those solutions right there. Again, lots of other ways to do this. We've got substitution, elimination, um, graphing. This is an easy problem when you end up with 16 equations and 16 variables. It's not as easy to do the substitution stuff. So this was a viable method for doing bigger problems. You wouldn't do it with a little dinky problem like this, but the pattern is the same, and so this is a good starting point for us. Let's try a couple more here. I didn't do my best at that, but I think it'll make sense as we do some more. All right, here's one, and I am going to write this as a matrix, augmented matrix. I've got 2, 3, 9, 4, negative 4, 8, like so. And remember that the whole goal here is to get something down here at the bottom that has 1, 0 number, 0, 1 number. Okay. That's what we're trying to move this into. I don't know if you've ever played with a Rubik's Cube, and you can kind of twist it this way and turn it and flip it upside down. That's a little bit like what we're doing here, and trying to make this work out and get it into the form that we want so we can read off the solutions here. All right. I'm going to start with trying to get this as a 0. This number right there, I'm targeting that one. I'd like to turn it into a 0. So in order to do that, I could take 2 times this 2 minus that one. The new row B be 2 times the old row A minus the old row B. 2 times 2 would be 4, minus 4 would give me the 0 that I want right there. But then I've got to do the whole thing all the way across. So now I'll write this one out. 2 times 2 minus 4. Here I've got a 3, so I'd have to do 2 times 3 minus a negative 4, and that would be 6 plus 4 is going to give me a 10 right there. When I do this one, I've got 2 times 9, 2 times the top number, minus the bottom number. That's going to be 18 minus 8 is a 10 right there. Okay, and I'm going to just keep the same thing on the top row, and we'll come back to that in just a second. All right. That took, we've done this one. we've got the 0 right there where we want it. And usually that's where you start with that thing. Just trying to get a 0 right there. If you can get a 1 on the row above it, that makes things a little bit easier. But see how I would have had to divide by 2? That would have been a 1. 3 divided by 2, that would be a fraction. 9 divided by 2 would be a fraction. To me, that just makes a mess, and I don't recommend that. But when I learned it, all the teachers said, yeah, just get a 1 there and deal with the fractions. It's an option. It works. Okay. Um, Next thing I'd like to do is to turn this guy right here. That's my target. I'd like to turn that into a 1. So if I could divide that whole row by 10, 0 divided by 10 would be 0. 10 divided by 10 would be 1, and I've got the 1 that I wanted, but I got to do the last one. 10 divided by 10 would be a 1. Okay? At that point, we're done with row number 2, and you can already see that this being y and the answer is 1, then I know that y is equal to 1. I've already got one of my solutions here. Let's see what we can do on top. Um, we could start working it here. Why don't we just write it one more time? Okay, I'll put the 2, 3, 9 and not do anything too crazy here. We'll move on that next one right here. This one's done. 0, 1, 1 on the bottom row. Let's see if we can fix the top row. And specifically, I'm going to target this number right there. I'd like to turn that into a 0. So in general, take this guy, get 0. Take this guy, get a 1. And now we can move on here in this stage. If we could get a 0 right here, then that would make us happy. Okay, what do I got to do that? Well, looking straight down, I've got that 1. I could either add or subtract 1. That doesn't help. I could add or subtract some multiple of 1. That sounds good because I could take 3 minus 3 times the 1, and that would give me a 0 right here, which is the whole goal of this next stage of this thing, next phase. Okay, so when I did that one, I had to take A, the new A, is going to be the old A minus 3 times the old B. So this one specifically was 3 minus 3 times 1 gave me the 0. Let's do that all the way across the row. Here I have a 2 minus 3 times 0. That's going to give me a, nope, not a 0. It's going to give me a 1 right there. Let me write that a little bit better. I got the 2 here, minus 3 times 0, and 2 minus 0 is 0, so this is still a 2 right there. All right, let's do the last one here. I got a 9 up top. That's the A, minus 3 times B, that's a 1, and that would give me a 6 right there. All right, you can see we're really close on this one, and maybe it's not even worth writing here, but I'm going to leave the bottom row the same. And then for the new A, all I got to do is divide by 2 because my goal is to get a 1 right here. Now I've got that diagonal matrix. This would be 2 divided by 2. Right here I had a 0, so 0 divided by 2 is still a 0. I had a 6. 6 divided by 2 would give me a 3 right there. I've got my solution where x equals the top number right here, 3, and y equals the bottom number in the last column, a 1 right there. That is my solution. Remember when you're solving these equations, you can always plug them back in and they should work, right? So if I go into the top equation 2 times, I just figured out x was 3, and here's a 3 times 1, Is that really 9? Did this thing work? This would be a 6 plus 3. That's a 9. That works, right? Down here, I'd have 4 times 3. That's 12. Minus 4 times 1. 12 minus 4 is indeed 8. So that is a solution that works. That's the only solution that works. Remember that these would be two lines that cross somewhere, and we want the coordinates of that point. Coordinates of the point are 3, 1. If we had done this the graphical way, the only point that satisfies both equations. Okay. Just like we saw with the other ways of solving systems of equations, sometimes weird things happen where the two lines never touch or where they're the same line. So I thought I'd throw one of each of those in here. Putting this into the matrix 2, 1, 1, 4, 2, 6. We've grabbed all the coefficients, put them in the right places. And now what I'd like to do is target this guy and try to get a 0 right there. So what I'm going to do that is I'm going to take, for the new B column, B row, rather, I'm going to take, let's take B minus 2A. We'll take the 4 minus 2 times 2, and sure enough, that gives me a 0 right there. 4 minus 2 times 2. I got to do the same thing here and here, though. So that would be a 2 minus 2 times the top number. 2 minus 2 times 1. 2 minus 2, that one's 0, huh? How about down here? I've got the bottom number, 6 minus 2 times 1. 6 minus 2 is a 4. Wait a minute. That line says that 0x plus 0y equals 4, or in other words, 0 equals 4. That cannot be true. When you see that happen, you know that there is no solution. Okay. And we saw those the other ways too. So sometimes the equations, just run parallel to each other, and you never get a solution. All right. But the process is still the same, trying to get that first number in the bottom left to 0. Also, sometimes this is the other weird thing that can happen here. Put it into the matrix. 3, 4, 12, 6, 8, 24. And even really just looking at this, see how 2 times 3 gives me 6, 2 times 4 equals 8, 2 times 12 is 24. That tells me that these are dependent equations, that they're really two versions of the same thing. It's the same equation, same function. We get busy. We target this guy right here, try to get a 0. And I'm going to leave this one alone. It's always an option to divide that by 3 and try to simplify the numbers, get them smaller, easier to work with. But I'm going to end up with a fraction in the second row, second column. So here again, I'd leave that alone until it's time to clean it up. Here, I could let the new values in B be equal to B minus 2A. I've got a 6 here. 6 minus 2 times 3. 6 minus 6 would give me a 0. That looks good. Here is a 8 minus 2 times 4. That one's 0. Here is a 24 minus 2 times 12. That's 0. Hey, wait a minute. I don't ever want a 0 row because that one says that 0x plus 0y equals 0. So 0 equals 0. That is true. But when you see that, you know that you're looking at infinite solutions because those are really the same line. Okay. So we'll leave that one right there and go try something else here. check this out. I don't know if you want to see this or not, but we said this was mostly built for crunching up bigger systems of equations. So here's one step bigger, still not a big set by some standards. 3, 4, -1, 18. 1, -1, -4, 5. And 2, 2, -2, 12. Okay. Now I'm going to try to do this as expeditiously as possible and not drag you through the mud too bad. But what I'd like to do is to get a 0 right there and a 0 right there. Okay. I would look here. Is it possible 3, 4, 18? I can't divide by 3 and get a 1 there yet. So hold off on that, in my opinion. I'm going to leave the top row the same. 3, 4, -1, 18 didn't do anything to the top row. Now I need to do something to get a 0 right here and eventually a 0 right below it. So what I'm going to do is 3 minus 3 times 1 would give me a 0 there. So right here, I'm going to take the top number minus 3 times the middle number there. 3 minus 3 times 1 would be a 0. Got to do that all the way across. 4 minus 3 times a -1, that's 4 plus 3, or a 7. I've got -1 minus 3 times -4, that would be a -1 plus 12, or 11. And then I've got on the last column there, let me just check my work here because I don't want to mess you up. I'd have that 18 on top minus 3 times 5. That's 18 minus 15 would be a 3 right there. Okay. On the bottom row, I want to get a 0 right here. So I'm looking at that 3, I'm looking at that 2, and the least common denominator, least common multiple there would be 6. So if I could make this a 6 and subtract a 6, that would work. If I take 2 times A minus 3 times B and do that all the way across, then I'd end up with a 0 right there, which is my prime objective right now. 2 times 6 minus 3 times 2. I multiplied the wrong number here. This is supposed to be a 3. 2 times the top number, 3, minus 3 times the bottom number would give me a 0. Do that all the way. I'd have 4. I'd have I'd have 2 times 4 minus 3 times 2. 2 times 4 is 8. Minus 6 is a 2 right there. Okay. On this one, I've got 2 times the -1 up top, minus 3 times the -2 on the bottom. That's going to be -2 plus 6 is going to be a 4. And then I've got 2 times 18 minus 3 times 12. That's 36 minus 36 is going to give me a 0 right there. Okay, hope that makes sense. I'm going to erase all this because I'm really going to need the room here. And I'll try to write a little bit smaller or something. All right. When I come in here, my next objective, it'd be nice to get a 1 right there, but I really want a 0 right there first. So let's see what we can do about that. All right. Maybe if instead we work this one and try to get a 0 right there. All right. What would that take? Well, I got this 4 up here, and 2 times 2 would give me 4. So 4 minus 4 would give me a 0 down there. Let's do that. We'll keep the same line on top. 3, 4, negative 1, 18. And I want to get a 0 there. So again, we got to take the top number, 4, minus 2 times the bottom number, C here, sorry. We got 3 rows now. And I probably goofed that up when I did this, didn't I? what did we do? A minus 3B. That worked fine. The 2A, this should have been a C, not a B. Okay. So now we've got our 0 there. This one would be the top number, 4 minus 2 times 2. There's my 0. When I do this one, I got a 3 up top minus 2 times 0. That's, oh, yeah, I should have done it the other way. A minus 2C. What did I do here? 2, 3, 2 times 2 minus 7 times 3. Okay, I actually went off script here a little bit. I worked this out beforehand. Let's do this a little bit different way. I apologize. If we go back to that top row like I just did and use A, it's going to put a number here, which undoes what we just did. Okay, so don't do that. Be smarter than me about this. Let's just work. Let's ignore. We're going to leave this one the same, and we're not going to touch it for just a little bit, all right? We're going to have to come back to that one. I definitely do want a 0 there, though. So now I'm kind of stuck working with these two numbers, and the least common multiple would be 14 on those. So if for this one, the new C, golly, the new C row is going to be, I got to get a 14 minus 14. So if I take 2 times the B row minus 7 times the C row, that would give me 14 minus 14 to give me the 0 right there. Okay. Fortunately, out here on the front, 2 times 0 minus 7 times 0, 0 minus 0 is a 0, and I maintain that 0 right there. When I do this one, I've got 2 times 11, 22, minus 7 times 4, 22, minus 28 would be a negative 6. And then I got to do the same thing for the last one. 2 times 3 minus 7 times 0, I'm really just down to the 2 times 3, would give me a positive 6 right there. Okay. And I didn't do anything with the middle row. So let's just copy that one in like that. Keep that one the same. All right. This incidentally is what we call a triangular matrix right there. See how it's all zeros on the bottom? I've got a triangle of numbers up top and zeros below that. So that's kind of good to do. Let's see what we can do from here on out. That bottom row is real simple to get that, right here. I'd like to get a 1 right there. Let's do that first. The new C is going to be take C and divide by negative 6. So I got 0 divided by negative 6 is 0. 0 divided by negative 6 is 0. Negative 6 divided by negative 6 is going to give me a 1. And 6 divided by negative 6 is going to give me a negative 1 right there. All right. At that point, we are done with that one. We're not going to change anything with row C again, but we can and will use row C to eliminate the number right above it, the 11. Let's go ahead and do that. I want to take the new row B is going to be the old row B minus, now I've got a negative 1, I'm sorry, a positive 1 right there. I'm trying to kill off this 11. This guy is my new target. And I want to get a 0 there so that I've got 1s on the diagonal. So to go from this 1 to the 11. I need a factor of 11. I'm going to take the old number 11 and subtract 11 times whatever's on the third row. Okay? So to do that, I would have to look right here, and I've got 0 minus 11 times 0. That's a 0. Right here on this one, I've got 7 minus 11 times 0 is just a 7. I move on to this one. I've got 11 minus 11 times 1, and that's going to be a 0 right there. Now I got to be careful here. I kind of cheated when I did these because I marked it here and here, but we're really using this number and this number and the 7 and the 0 over here. Okay, so watch out. This time I got to use the 3 and go 11 times the negative 1, 3 times 3 times negative 11 times 3. Something scooped up here. Let's see. Oh, yeah. 11 times negative 1 would be a negative 11. So 3 minus a negative 11 would be 3 plus 11. And I'm going to get a 14 right there for that one. All right. If I write that one out, then I've got the 3 over here minus 11 times 1 times negative 1, the number right there. Okay. Negative 11 times negative 1 is positive 11. 3 plus 11 is going to be 14. I got that one. Let's go ahead and make our next matrix with that. Keeping the bottom row the same, 0, 0, 1, negative 1. Now you can see that I want to get rid of that 7, turn it into a 1. So the new b is going to be the old b divided by 7. So I'm dividing everything on the second row by 7. 7 divided by 7 is 1. 0 divided by 7 is 0. 14 divided by 7 is 2. I've got 2 rows done at this point. Done, done. I just got to fix the top row. Now I got to flip it around one more thing. I want to get a 1 right here. That is my new target. Fix this guy. Right now, it's a 3. So what I can do here, and you know what? Before I even do that, let's do one more thing first. Let's not go after that one. Let's actually go and here you could do this in 2 steps. I'm going to do this in 1 step because I think you're tired of seeing this already. I'm tired of looking at it. But let's get a 0 here and here. Let's turn this 4. Let's go after this one and this one and see if we can't turn both of those into zeros. And if so, we'd be getting pretty close on this thing. What do I got to do there? All right. If I take the original row A, one that's over here, I want to turn that 4, and I'm looking down here. I've got that 1. I can use this 1 and this 1 to eliminate the stuff above it, essentially. So I'm kind of working backwards back up the row, and so why don't we just write this and see what we got? I got a 3, I got a 4, I got a negative 1, I got an 18. And again, we're going to go after this one and this one. Again, you could do it 2 steps. I'm going to try to finish this up before y'all die of boredom and kill both of those off at the same time, keeping everything else the same. 0, 1, 0, 2. Okay. Let's in order to do this, I've got it here. I'm going to take the top row, the old top row, the numbers that we've got there in red, and I'm going to subtract 4 times the second one, and I'm also going to add the bottom one. Okay. If I do that, then I've got 3 minus 4 times 0 plus 0, and that's going to give me a 3 right there. For the second row, second column, I've got that 4 sitting there. I'm going to subtract 4 times the 1 that's straight below it, and then I'm going to add the 0 that's below that. 4 minus 4 is 0, plus 0 is still 0. So remember, that's what we were trying to do, turn that one into a 0, and also this other one, the -1. If I take the -1 and I subtract 4 times the number that's straight under it, 0, and add the number that's 2 steps down there, plus 1, this is 0, -1 plus 1 is 0. Got to do it to the last one, though. Here, let's try one last thing. 18 minus 4 times the number straight under it, 2, plus the number that's under that. Okay, that would be 18 minus 8 is 10, minus another one would be a 9 right there. All right, we got one last matrix to do here. Nothing is changing on the bottom row. Nothing is changing on the middle row. This is top row, and all I got to do is turn that 3 into a 1. I've got my zeros everywhere I want. Just divide through by 0. 3 divided by 3 is 1. 0 divided by 3 is 0. 0 divided by 3 is 0. 9 divided by 3 is 3. Phew! The good news is we are done, okay? When I look at the last column right there, understanding that these represent my x's and my y's and my z variables, I end up with x equals 3, y equals 2, z equals -1. Those are the solutions to those 3 equations. And again, you can do that with substitution. It's going to be real hard to do with graphing. Substitution might be your only bet on that. But here's a way to do it with elimination. You might could do it with elimination method if you work at it. That's kind of sort of what we just did. The matrix saves you writing, saves you stuff, and does all right. Now, I would like to show you that again, this is kind of the 1800s approach to doing this. And today we do have a calculator. So what I'm going to do real quick here is come in and hit second matrix to pull that up. I want to edit a matrix, and you know what? Let me go back, quit, and we'll get a blank brand new matrix. Second matrix, let's go down here to matrix G. We haven't used that one yet, and I still got to edit it. So down, down, down to G. Okay. I need 3 rows, 4 columns here to hold the X's and the Y's, the Z's, and the numbers. So 3 rows, enter, 4 columns, enter, put your numbers in. 3, enter, 4, enter, -1, enter, 18. There's my top row. I got 1, -1, -4, 5 for the second row, and 2, 2, -2, 12 will finish that up. Make sure you hit enter on the last one. Make sure that that actually goes to 12. But now I have this matrix in my calculator. I can quit. All right. Hit second matrix again. And this time we're going to step over to the math menu. And you can go up, you can go down. It scrolls over the top. It's actually a little bit shorter if you go up. But there's RREF on the calculator. And remember, that's what we were trying to do. This is the RREF version of it down here at the bottom that gave us the solutions. And so I want to do an RREF um, on this matrix and see what I get. So hit enter. You got to tell it which matrix you put your numbers into. We were in matrix G, so I'm going all the way down there. Hit enter, and it's ready to go. All I got to do is hit enter, and 3, 2, -1. Those are the same numbers that we just pretty laboriously found, just spit out like that. So the calculator does make this a lot easier. You do have to have a calculator that will handle matrices. I never had one that would handle matrices until I got into grad school. That's about the time they invented this stuff. Before that, we were doing all this by hand, and I used to be pretty good at it. Um, Sorry for my blunders today, but that is Gaussian elimination. Thank you, Mr. Gauss, and I'm glad we don't have to do it anymore. But here is there's a little cheat sheet here. If you can copy paste that, I've got a little cheat sheet that shows you the steps to doing this. I'm going to pull it up real quick here so that you can see that. And I'll put it on the screen. You can screenshot it if you want. But here's the thing that I typed up for my physics students because they have to do these all the time, especially in electricity. And okay, whatever. Um, there, why can't I get the whole thing? Okay. If you want it there, you can screenshot it. There are kind of 3 steps to this. You do have to edit the matrix, put the thing into your calculator. Then you got to operate on the matrix, which means you got to get RREF. And then you got to tell it which matrix you want to RREF in the first place, and it'll give you the solutions over there. Okay. And again, you can get that off my website. You would have to go to the physics 2 people. That's who needs it. And down here, there's a little link to it. But let's do this last one here one more time just to see that whole process one more time. Again, like I said, there are 3 steps. And I got to clear the decks here so I can get back to my magic thing. Okay. The first thing that we want to do is to edit the matrix. Put it into your calculator. All right. So I'm going to come over here. I'm going to hit clear. I'm going to go second matrix, and I have to go over to edit. And I'm going to pick a matrix that I haven't used yet. That D is sitting there. I could use any of the ones I have, just redefine it to whatever I need, but we'll go with this one. Okay. You got to count how many rows, 1, 2, 3 down. How many columns? That would be 4 columns. So we got enter. We're hitting 4, enter. I got 1, -3, 4. That's my first column 3 there to finish it up. Steps down to the next one. Every time you hit enter, it moves to the next box, and you just put in the numbers. -3, 3, 4, 6 is the bottom row. Okay. I have now edited my matrix, so I need to exit. And that's just going to be the second quit right here. All right. Next up, I need to tell it to do the RREF of that matrix. That is in the math menu. So I'm going to go second matrix, step to the middle one, and go up or down. There's RREF. And now it's ready to change some matrix into an RREF. I got to remember which ones I did. I think it was D. I hope so. But that's the third step. pick the right matrix. I'm going to go with D because I think that's right. Uh, so one more time, second matrix. Anytime you want to do anything, you got to do the second matrix thing. And there are the solutions if I pick the right one. And you can see that X would be 10 and a half, and Y is 7.5, and Z is 3 3/4, 3.75, whichever way you want to do it. Doing the Gaussian elimination by hand with that one would be pretty nasty. See how they're all decimals or fractions? And that makes things extra fun. I kind of picked one that didn't have any fractions to it. And sometimes you can dodge it and, do things that save you getting into that. But is still a pretty good trick. All right. That's everything I've got about Gaussian elimination for you. Have fun with that. In real life, you're going to use the calculator, but I would like you to kind of walk through, especially some of those easier ones, the 2 by 2, the two equations, two variable kind of things. But thanks for listening. If you made it this far, have a great day. Be well.